Hey, welcome. Today, we're going to dig deep. Literally. We're talking about the incredible forces that are constantly reshaping our planet, from its super hot core all the way to the very ground under our feet.
We all kind of take it for granted that the ground is solid, right? That it's stable, permanent. But what if it isn't? What if it's actually moving all the time in this constant, super slow motion dance? Well, that's the wild reality of our planet.
All right, so first step, the restless ground. To really get what's happening to our planet, you have to start with this one big idea. The Earth's surface is not still, not at all. It's more like a giant, ever-shifting puzzle. So, see, the Earth's crust isn't just one solid shell. Nope, it's actually broken up into these massive pieces called lithospheric plates. The best way to think about them is like giant rafts, just floating on this sea of gooey, semi-molten rock. And they are always on the move. I mean, it's slow, maybe just a few millimeters a year, but that tiny movement is powerful enough to push up entire mountain ranges. It's actually why the Himalayas are still getting taller as we speak. So, what's giving these huge plates a push? Well, the engine for all this is buried deep, deep inside the Earth. The crazy heat from the planet's core creates these slow but super powerful currents in the molten magma, kind of like watching water boil in a pot, but on a planetary scale. These are called convection currents, and they're the engine driving the whole show. Okay, so this is really the key to understanding everything. There are two major types of forces shaping our world. You've got your endogenic forces, which, as the name suggests, start inside the Earth. Think volcanoes, earthquakes, the dramatic stuff. Then you've got exogenic forces, which work on the outside, on the surface. We're talking about wind, water, ice. And it's this constant battle, this push and pull between these internal and external forces that sculpts the world we see.
Let's start with those powerful forces from within, the endogenic forces. These are the ones that cause sudden, really dramatic changes to the landscape.
This quote is just a perfect description of a volcano, isn't it? A volcano is basically a weak spot, a vent in the Earth's crust, where all this superheated rock, gas, and ash from deep inside just bursts through to the surface. It's spectacular and, yeah, often pretty destructive. And what about when those giant plates we talked about don't just drift, but grind against each other? Well, a ton of stress builds up along those cracks, the fault lines. And when that stress finally gets to be too much, it releases in a sudden jolt, sending these powerful shock waves or vibrations through the ground, and that's an earthquake. Now, this is a really important distinction. The focus is where the earthquake actually begins, way down deep in the crust where the rock physically breaks. But the epicenter, that's the spot right above it on the surface. And that's exactly why the epicenter is almost always where the worst damage happens. This chart really puts the power of earthquakes into perspective. You see, the Richter scale is logarithmic. That means a magnitude 7.0 earthquake isn't just a bit stronger than a 2.0. No way. It's actually thousands of times more powerful. We're talking the difference between a little tremor you might not even feel and an event that can cause just widespread devastation. And this isn't just theory. To give you a real-world example, a massive 6.9 magnitude earthquake hit Bhuj in Gujarat, India, back in 2001. It was an absolutely tragic reminder of just how destructive these internal forces can be. We can't predict when an earthquake will happen, but we can definitely be prepared. The most important thing is to get to a safe spot, like under a sturdy table or a kitchen counter, to protect yourself from anything that might fall. And you've got to stay away from things like windows, mirrors, or even fireplaces. Okay, so while those forces from within build things up with all this sudden, violent energy, the forces on the surface, the exogenic forces, are more like patient sculptors. They are constantly at work, wearing down and reshaping everything. And the two main tools these sculptors use are weathering and erosion. They work together. Think of it this way. Weathering is the process that breaks the rocks down into smaller bits, and erosion is the process that carries those bits away, using things like water, wind, and ice. And what's so cool is that each of these agents of erosion leaves its own unique signature on the landscape. Rivers carve out deep valleys and create those gorgeous waterfalls. Sea waves are constantly battering the coastlines, forming caves and dramatic arches. Glaciers, they're like giant bulldozers, just plowing through. And wind can sculpt a desert into something that looks like it's from another planet. Here's a perfect example of that slow, patient sculpting I was talking about. So first, the waves find a weak spot in a cliff and carve out a cave. Then, Over thousands and thousands of years, they just keep going, breaking all the way through the other side to form a sea arch. But it doesn't stop there. Eventually, that arch gets weak and collapses, leaving behind this lonely pillar of rock called a stack. Amazing, right?
I absolutely love this description, rivers of ice. It just perfectly captures what glaciers are. They're these immense, incredibly heavy bodies of ice that are actually flowing, just really, really slowly. And as they move, they grind and scour the land beneath them, carving out whole valleys and leaving behind these huge piles of rock and dirt called moraines.
And out in the desert, wind is the master sculptor. It picks up sand and basically sandblasts everything in its path. But here's the cool part. The wind can't lift the heavier sand particles very high off the ground, so it eats away at the bottom of rocks much faster than the top. And what you're left with are these incredible, top-heavy structures that look exactly like giant mushrooms. So what does it all mean when you put it together? When you combine the explosive forces from below with the patient sculpting from above? Well, you get a planet that's dynamic, beautiful, and fundamentally unfinished. This is really the grand story of our Earth. It's a constant tug of war. You have the endogenic forces from deep inside, thrusting up mountains and creating new land. And at the exact same time, you have the exogenic forces on the surface, working tirelessly to wear it all down and carry it back to the sea. And that's the big takeaway, isn't it? Our Earth is an ever-changing masterpiece. Every single process, from a violent volcanic eruption to the gentle lapping of a wave against the shore, is like another brushstroke on a canvas that is never, ever going to be finished. Which kind of leaves us with this one fascinating thought to chew on. If these unbelievably powerful forces of creation and destruction are always at work, what kind of world are they building for the future? If you could hit fast forward and see the Earth 1,000,000 years from now, what would it even look like? Something to think about. Thanks for tuning in.